So today I have some atta with me, and in this video we will learn how to make chapatis. Well, no, that's a joke. We will learn the formula to find the volume of a cone. So here I have a cone with me. This is a simple cone made out of paper, and this cone does not have a bottom. We will learn why so. So this has only the curved surface area, not the bottom. Okay, so this is a hollow. This is a hollow cone. Now, how do we find the volume of any object? Well, firstly, what is the volume of an object? The volume of an object can be defined as its capacity to hold any fluid. Let's see. So, for example, if you have a bottle or a container like this, how do you define its volume? Well, I may say that this can hold, let's say, 250 ml of water, or your bottle could hold 1 liter of water. So, that is how you define volume. Similarly, we can find the volume of this cone by filling it up with some fluid. The problem is that this is a paper cone, so I cannot fill it up with water. But then I have atta here, so I can fill it up with atta, and I'll just show you how you can use atta and the paper cone to find the volume of this cone. So I'll start filling this up with some atta, and yeah, don't try this at home. This is a very dangerous experiment. You may get beaten up by your mother for wasting atta. But anyway, so I filled this up, and now I'll pour it into. So I filled it up, and I'm going to pour it into this container. So before I pour it into this container, what I would like to show you is that what shape is this? If you see, this is almost similar to cylinder. Why did I say similar? Well, because it is not exactly a cylinder because this has curved edges. But yeah, this is a good approximation to the volume of a cylinder. Now, what is special about this container and this cone is that they have the same base area. So if I put it this way inside the thing, I can wait. That's not possible, but yeah, you can just see they're exactly the same. The base area is exactly the same. So yeah, they have the same base area, which means they have the same radius, and they also have the same height. And I believe you can see that there. See, they have the same height, almost the same height. So what we are trying to compare is the volume of a cone and a cylinder. The cone and the cylinder have the same height and the same radius. So I'll just transfer this. This is a tedious task. So I've transferred all the atta from this to that, and if you see, if you can see in that container, I've got approximately this much atta there, so I can still fill it up. So let me try to fill the container, the cone again with atta, and let's see how many cones can you fit into that. So I've again filled the cone for the second time with atta, and now I'm going to transfer the atta from the cone into this container again very carefully. I'll just use my hand. So I filled up the container for the second time with atta. So till now I've managed to fit two completely filled cones of atta into this, and still I can see there's quite a lot of space in the container. So I'll go for a third time. So I have filled the cone for the third time with atta, and you can see it's completely filled. And now I'm going to transfer this third cone of atta into the container. So here I go with complete care, transferring, and yeah. So now we can see that when I emptied the cone for the third time into the container is completely filled. And when I say completely filled, it's exactly completely filled. And that is an interesting result. I was able to fit 3 completely filled cones of atta into this container, while this container had the same height and the same radius, which means the volume of this cone is 3 times less than the volume of this container. Or in other words, the volume of this container, which is a cylinder, so the volume of this cylinder with the same height and the same radius is thrice or 3 times the volume of a cone with the same height and the exact same radius. So I'll just show you that on paper what that means, but I need to get rid of this. So there I go. So now what was the result? So the volume, wait, I'll just take one sheet. So the volume, sorry for the handwriting, volume of cylinder, that equals, so what is the volume of a cylinder? We've seen in the previous videos, the volume of a cylinder is pi r squared times h, the base area times h, that is the volume of a cylinder. So the volume of the cylinder is pi r square h. So if I take the volume of the cone, the volume of cone equals volume of cylinder. So the volume of the cone is equal to the volume of the cylinder divided by 3. This is what we just saw, right? If we take the volume of the cylinder that we have taken, we had to divide that by 3 to get the volume of the cone. In other words, we could fit 3 cones into that cylinder with the same height and the same radius. So what is the volume of cylinder? We can just put in this expression. So the volume, I'll just write volume, which means the volume of the cone, equals pi r square h upon 3. What is h? H is the height of the cylinder, but we just saw that the height of the cylinder was exactly equal to the height of the cone. So h is the height of the cone. R is the radius of the cylinder, but that was also the radius of the cone. So r is the radius of the cone, h is the height of the cone. So if we have, in short, if we have a cone with radius r and height h, the volume of that cone will be pi r square divided by h. That is how you find the volume of a cone. That is it.